Hello and welcome to the video. In this video, I'm going to be talking about linear inequalities and some questions based on the modulus functions along with inequalities involved. While doing the questions, I'm going to introduce you to the concept of inequalities and also how modulus function works. This is just a video on a few questions only, so I'm not going to be going in detail about the concept. However, I'll try to touch upon them as much as possible. So when we talk about equations, we're going to have something like this: x is equal to 2 or 2x plus 3y equal to 4. These are going to be linear in nature because the degree of the equation is 1 and it is having an equal to sign. However, if I convert this to less than 2 or x greater than 2 or x less than or equal to 2 or x greater than or equal to 2 or even x not equal to 2, all these come under bracket of inequalities. Okay, this topic is necessary with respect to IIT JEE mains, even for advanced. ICSE students learn about this in 10th standard. CBSE people, CBSE students, they do not. Okay, so for CBSE students, this might be a new topic, but it's not a very difficult topic to learn. Let's look at the first question here right away. So the first question says 3x plus 4 is less than 16. Well, this question is a very simple question. You solve it as how you solve an inequation. All right. So here you'll have 3x is less than 12, which means x is less than 4. Very simple. However, let me introduce you to a concept of a replacement set and the solution set. Replacement set and then the solution set. Now, what's a replacement set? Replacement set is a set from where I pick up the solution. Okay, so a replacement set can be a set of natural numbers, it can be a set of whole numbers, it can be a set of integers, I or a z, and then rationals, and then real numbers, of course. All right. So when I say that the value for x belongs to n and then give me the solution set, in that case my solution set is going to be equal to 1, 2 and 3 only. And if I say that the value for x is belonging to whole numbers, then my solution set is going to be 0, 1, 2 and 3. All right. And if I say that the replacement set belongs to set of integers, which is I, then the solution set is going to be anything below 3 and equal to 3, which means minus 1, 0, 1, 2 and 3. So anything below this will be the solution set. Most of the time, for at least IIT JEE students, they do not give you the replacement set. It is understood that the replacement set is the set of real numbers. Now, real numbers, as we all know, it's a set of all the decimals and fractions and integers and everything, right? So we really cannot list all the elements in this type of a format. People who have learned set, they know that there are three ways of writing a set. One is a description method, and then we have the set builder method or the rule method, and then we have the roster method. Now this is the roster method of representing a set. So I cannot list out all the elements belonging to real numbers, and therefore when the value for x is belonging to real numbers, then my solution set will be written something like this: minus infinity till the value 4, but not included. 4 not included. So again, I know a lot of concepts here. Here I'm talking about representing solutions with respect to the brackets, intervals, and all of that. Okay. On the number line, if I had to represent this particular solution, it would be 4 over here with a hollow circle indicating that 4 is not included and anything below that. All right. As I said again, ICSE students learn all of these. CBSE students is going to be new. However, I'm going to limit myself to this particular concept and then move on. So that is going to be my solution set. Another way of writing this is minus infinity less than x less than 4. Just another way of writing the same solution. Let's go to the second question now. 8 minus x less than or equal to 4x minus 2. 8 minus x less than or equal to 4 minus 2. This question again, we solve it as normal. which is transposing the variable to the left hand side and the constants to the right. So when I do that, I'll have a minus x minus 4x is less than minus 2 and then a minus 8. So this is going to become minus 5x is less than minus 10. If this was an inequality, if this was an equality, I would have gone ahead and said that x is equal to 10. However, in inequality, we don't do that. Let's understand why. We all know that minus 3 is less than minus 2, right? Because on the number line, minus 3 is towards the left and minus 2 comes towards the right. And therefore, minus 3 is going to be lesser than minus 2. However, when I multiply this with a negative sign, what happens? I get a 3 and then a 2. So 3 is not less than 2. 3 is actually greater than 2. So one of the rules of inequality is this. If I have x is less than y, and then I'm multiplying x and y with a negative sign, then the inequality has to change. It's the same thing if x is greater than y, then the inequality will again change like that, right? So in here, first I'll take care of the inequality, which is 5x is going to be greater than 10, and that tells me that x is greater than 2. X is greater than 2. Again, here the replacement set is going to be a set of real numbers. If not mentioned, please consider it to be a set of real numbers. And how do I write this? Two different ways, using one interval or the set builder method. So x will simply belong to 2 and about 2. Anything with about 2 until infinity. What is the other way of writing this? The solution set is simply equal to x such that 2 less than x less than infinity. Or you can simply say x is greater than 2. That's also fine. Okay. Again, if the replacement set is not mentioned, it is understood that it is a set of real numbers. So here we have 3 inequalities or 3 binomials with 2 inequalities. We can continue to work with it like this, or we can divide it with we can divide this into 2 different inequalities. How? We can write this as 2y minus 3 is less than y plus 1, and y plus 1 is less than or equal to 4y plus 7. Bear in mind that I'm using the word and, which also means intersection with respect to sets. Now, what does that mean? Let's quickly look at this one. It's pretty unfortunate that you people learn linear inequalities without learning about sets. I have noticed some institutes do that. That's okay. It's not a lot of information that you need to know. Just a little bit of it, that should be good enough. So this is 5, and then let's take another set, which is, let's say, 4, 5 and a 6. So when I say A intersection B or A and B, it would simply mean 4 and 5. Basically, the common elements are belonging to the set A and to the set B. That's what it means. So let's go back now. So again, I transpose it around like how I do it for an equation itself. So this is going to become 2y minus y is less than 1 plus 3, which means y is less than 4. And here, when I transpose it, I'll have y minus 4y is less than or equal to 7 minus 1, which means minus 3y is less than or equal to 6. Take care of the inequality by multiplying by the negative sign. So 3y is greater than or equal to minus 6, which means y is greater than or equal to minus 2. Y is greater than or equal to minus 2. Well, you can either write the solution through observation, or you can probably figure it out, right? So this is 4, anything below 4 is a solution here, and the next one is 0 here, and then we have a minus 2 here, and minus 2 is included, and anything above. So what's the common region here? The common region is from this point to this point, right? Now that's going to be the common region. And how do I represent the common region? This would simply mean that y is belonging to minus 2 included till 4, and 4 is not included. Now this is the interval way of writing the solution. And what is the roster method? Well, I can simply say minus 2 less than or equal to y less than 4. No, this is the set builder method, not the roster method. We cannot write a solution for real numbers in roster method. So that's your solution. If you want to, you can also write it like that. Y such that -2 is less than or equal to y and less than 4. Let's look at the next question now. So this question has two different sets, and these two sets have been given in the roster or the rule method, sorry, or the set builder method. Pretty straightforward. What is the value of x which is less than greater than -2 and less than 6 and greater than 2 and less than 8? Well, it's pretty easy to figure this out. You can draw the number line if you want to. 0, -2, and then a 6. 6 is included, 0, -2 is not included, and the next one is write 0 at the same spot as the earlier equation. 8 over here, and then a 2 over here. 2 is included, 8 is not included. What is the common region? Well, the common region is from this point to this point. So in both the cases, the extreme values are included. So 2 less than or equal to x less than or equal to 6. That's your answer. Okay, pretty simple one. Let's look at the next one. The next question involves modulus and an inequality. It involves a modulus and an inequality. We'll first understand what is a modulus function. A modulus function, which is y is equal to mod x, is actually a piecewise function. Piecewise function. Now, what does a piecewise function mean? It simply means that two pieces of two different functions are put together and made as a function. Basically, it's equal to -x when x is less than 0, and then x when x is greater than or equal to 0. Let's look at the graph of this very quickly. So that is your mod function. Looks like a V. And if I could plot another equation, let's say -x and then a +x. So I'm going to hide -x here. So you can see that -x is overlapping with the mod function, and +x is overlapping with the mod function. So a mod function is pieces of two different functions put together. So below x equal to 0, that's a 1, and then below above greater than or equal to 0, that's going to be the function. So we are identifying. So let's look at this question here. Before we can, I have told you that if I have mod x to be, let's say, less than 2, then x will be between 2 and +2, -2 and +2, right? But in this question, please do not attempt that, because you might not be able to get the solution. What you need to do is to first take an LCM here. You get that? So what we know is that x squared plus 1 is always going to be positive. All right. So mod of x squared plus 1 divided by mod x is greater than 2. So mod of x squared plus 1 is simply going to be a mod x squared plus 1 itself. So you can take out the mod from there. Now it's a mod x, which means even if I transpose it to the right hand side, it will be positive. The inequality will remain the same. Transpose it to the left hand side, so you'll have x squared minus 2 mod x plus 1 is greater than 0. Now x square can be written as mod x the whole square minus 2 mod x plus 1 is greater than 0. Now this is simply mod x minus 1 the whole square greater than 0. Now this is true for any value of x. This is true for any value of x except for the value of x as -1 and +1, right? So x cannot be equal to -1 and +1, and therefore the solution set is going to be all of real numbers except for -1. And also please remember that x cannot be 0, because if x is 0, then this is going to be a 0, and that's going to be an infinity or undefined. So 0 and a plus 1. Except for these three values, the solution set is that. Let's go to the next question. Now the next question has two different ways of solving it. One is a very lengthy way of solving it, and there's one more easier way. I'll tell you how the lengthier way goes. I'm not exactly going to use it to solve it, or let's see if I can actually do it. All right. So we have three mod functions, and that's been put in an inequality which is greater than or equal to 6. For this question, I'm going to be dividing this into multiple intervals and trying to identify what is going to be the function, how is the function going to behave in that particular interval. So I'm taking x minus 1 is equal to 0, so which means x is equal to 1. Likewise, I get 2 and a 3. So I'm going to divide this into these intervals. So I'm going to find out the behavior in this interval, in this, and this. So let's start with the x is less than 1. All right. So when x is less than 1, then this is going to be a negative function. For any value of x as less than 1, this is going to come out to be a negative. Obviously, we're taking a mod, but before taking the mod, this is negative and this is also negative. All right. So what happens when x is between 1 and 2? Between 1 and 2, this is going to be positive, whereas this is going to be negative, and this is going to be negative. What happens from 2 to 3? This is going to be positive, positive, negative. What happens above 3? Positive, positive, positive. So we will have 4 different cases. So we'll have to solve for 4 different cases now. Let's see. So let's go with case 1. For case 1, I'm going to say x is less than 1. So for x is less than 1, we will have what? A negative function here, a negative function here, a negative function here, and that's going to be greater than or equal to 6. So this is a minus x plus 1, minus x plus 2, minus x plus 3 is greater than or equal to 6, which gives me minus 3x is minus 3x plus 6 is greater than or equal to 6, which means minus 3x is greater than or equal to 0, and that will tell me that the value for x. So here again we will be changing the inequality and then say x is less than 0. Then we have case 2. This is case 1 and this is case 2. In case 2, I'm going to consider x to be between 1 and 2, and when I'm doing that, this is going to be a positive function, whereas this is going to be negative, and this is going to be a negative function. Greater than or equal to 6, open the brackets up, you will have x minus 1 minus x plus 2 minus x plus 3. Here you're going to have minus x plus 4 is greater than or equal to 6, which means minus x is greater than or equal to 2, which means x is less than or equal to minus 2. Next, case 3. So under case 3, I'm going to consider the x value to be between 2 and 3. So between 2 and 3, obviously this function is going to be positive. This function is also going to be positive, whereas this function is going to be negative. So you're going to have x minus 1 plus x minus 2 minus x plus 3 is greater than or equal to 6. So x will get cancelled, so you'll have 0 over here. So basically x is greater than or equal to 6. X is greater than or equal to 6. Let's look at case 4. Case 4 is when x is greater than 3. When x is greater than 3, all the functions are going to be positive. So x minus 1 plus x minus 2 plus x minus 3 is greater than or equal to 0, 6, sorry. So 3x minus 6 is greater than or equal to 6, which means 3x is greater than or equal to 12, and x is greater than or equal to 4. X is greater than or equal to 4. So those are my cases. Now let's understand this. For x is less than 1, x is less than 0 is making sense. For x belonging to 1 to 2, this does not make sense. When x is belonging to 1 to 2, x cannot be a minus 2. So there is no solution here. And then we have from 2 to 3. From 2 to 3, x is greater than 6 does not make solution. Does not make any sense. So there is no solution here. How about this one? This makes sense, which is x is greater than 4, equal to 4. That makes sense. So combining the solution, I can say that x belongs to minus infinity to 0 with 0 included, union 4 to infinity. Now let's go back and look at the question. From the question, I know everything seems to be fine. So yes, that's going to be a solution. Now there is another way of solving this question. What is the other way? We know this, which is mod of a plus b is less than or equal to mod a plus mod b. So I can use this over here. What does that mean? I can simply write mod of x minus 1 plus x minus 2 plus x minus 3 is less than or equal to mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3, which is less than which is less than 6, right? Which is less than 6. So here the question talks about greater than or equal to, but I'm considering this. So let's see, what does this mean? This simply means that mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3, sorry, is less than 6, right? Which means mod of 3x minus 6 is less than 6. What does that mean? This means that 3x minus 6 belongs to this particular interval. So when you add a 6 all over, this is going to be 0 less than 3x less than 12, which means 0 less than x less than 4. So when it is less than 6, this is the solution. So what's the solution when it's greater than and above 6? The other way around, which basically means that x belongs to minus infinity to 0, minus infinity to 0, union 4 to infinity. Now this is a very easy way of solving it, right? You don't need to do case 1, case 2, case 3 and all of that. So that's the end of the video, right? We looked at different topics and different concepts here. Linear inequalities with the modulus function. So we understood what is the meaning of a replacement set, what is the meaning of solution set, and how to deal with intervals, what happens when we are dealing with an inequality and a negative number, and so on and so forth, right? And some interesting questions with respect to modulus function, right? I hope this video was helpful for you. Thank you very much for your patience. Goodbye.